What we're demonstrating here today is the reaction between hydrochloric acid and magnesium ribbon. The reaction is going to produce some hydrogen gas, which we are going to collect, and it's also going to produce some magnesium chloride, a salt, which is soluble, so it will dissolve, and so we won't see that. So for this reaction then, what I'm going to do, I am going to measure out some hydrochloric acid in this measuring cylinder. Now, I need to get 20 milliliters of the acid, so I'm going down to eye level and I'm measuring out the 20 milliliters now. That's spot on. And then I'm going to pour it into this boiling tube here. Now I'm going to add a 3 centimeter piece of magnesium ribbon to the acid. I'm going to place the bung on, start the stopwatch, and every 10 seconds I'm going to measure the volume of hydrogen gas being produced in this measuring cylinder here that is currently full of water. So here goes. There's the magnesium going in. You can see it starting to fizz through. Put the bung on, start my stopwatch, and again I've got to get down to eye level to actually measure the volume of hydrogen gas being produced. Now you should be able to see it fizzing in the boiling tube there, and now we can see the bubbles of hydrogen gas collecting in this measuring cylinder. So 10 centimeters is gone, and really what I need is a partner. I need one person looking at the stopwatch telling me when 10 seconds is gone, and then myself looking at the measuring cylinder all the time and shouting out what the readings are. Now, we need this reaction to carry on, or we would carry on doing this experiment, taking readings every 10 seconds until it stops. But I'm going to talk to you now about some of the hazards and risks associated with this investigation. We're using hydrochloric acid, and that's an irritant. So the first thing we do, we wear a pair of goggles to protect our eyes. To protect our skin, we could wear a pair of gloves. I'm not today, so if any acid was spilt onto my skin, I would go over to the sink, put the tap on, and wash that acid off my skin. Now, the object of this investigation is to find out what happens to the speed of the reaction, the rate of this chemical reaction when we change something. We are going to change today the strength of the acid. It's a little bit like when you're at home and you're having a glass of squash. You put some squash into a glass, you top it up with water, you dilute in that squash. It's not as strong, so we're going to do the same to our acid. So I'm going to assume now that this experiment is over. So I'm going to reset this measuring cylinder, now fill it up with water, put it back up on there, and then I'm going to empty this boiling tube with the current contents. And now what I'm going to do, this time I'm only going to measure out 10 milliliters of acid. Again, going down to eye level. Turn that round so I can see the scale. Add this slowly now because I only want 10 milliliters. And there we are. Pour that into the boiling tube. And now to dilute that, I'm going to add 10 milliliters of water, keeping the total volume the same, 20 milliliters each time. Okay, there's my 10 milliliters of water going in there. So that acid now is diluted. So I need to put the delivery tube back over here. Reset my stopwatch. Again, getting a 3 centimeter piece of magnesium ribbon. I'm going to drop that into my less concentrated acid now. Start my stopwatch. Every 10 seconds, take a reading on the measuring cylinder. Let's get that right. Here we go. Put the bung on. Start the stopwatch. Going down to eye level again. Every 10 seconds, measuring the volume of gas. Now you can see it is fizzing in the boiling tube, not as much. And already we haven't got any gas coming through here. This reaction is definitely slower. Now the reason for that is this. There are less acid particles now in that boiling tube. So there's less collisions between the acid and the magnesium. So the reaction is going to be slower. Now we're only doing this experiment once, okay? We could make mistakes. To get results that are trustworthy, we need to repeat each of these experiments at least twice. We also need to have a range. I've used 20 milliliters of acid and no water. And in the second experiment, I used 10 milliliters of acid and 10 milliliters of water. I've only got 2 concentrations there. And we're saying in the less concentrated, the reaction is slower. What we need to do is 4 or 5 different concentrations, so we get a larger range of readings, giving more validity to what our conclusion would be. Now, as I said earlier, it is quite hard to take the readings of the volume of gas using this measuring cylinder. So what I'm going to show you now is another way in which we could do the same experiment, but making the measurement of the hydrogen gas a lot easier and far more accurate. So I'm going to stop this experiment and I'm going to bring another set of equipment over here. Just move these out of the way. Okay, what I have here is a conical flask. There's the bung, delivery tube, and this is a gas syringe. What will happen as the gas is produced in here, the pressure of the gas is going to force this plunger out. And as you can see, there's a detailed scale on here, which is easy for me to read as the slider is moving out. So I'm going to do this experiment for you now, again, using 20 centimeters cubed or 20 milliliters of acid. So I'm going down to eye level, measuring out this in a measuring cylinder. And again, I'm using a small measuring cylinder here. I'm not using a big measuring cylinder. This measuring cylinder is a 25 milliliter one. So the scale is quite sort of stretched out. It's easy for me to see that 20 milliliters. If I use the big measuring cylinder, I'd be looking somewhere down here. The scale will be quite crunched. It'd be harder to get those accurate readings. So I'm going to pour that in. Over here. Again, get my 3 centimeter strip of magnesium ribbon. I'm going to pop that in there, put the bung on, start my stopwatch, and again, every 10 seconds, taking a reading off the gas syringe. So let's put that in, put the bung on, start the stopwatch, and then we need to, every 10 seconds, look to see where this is. Now we need to talk about variables in this investigation. In our original one, the independent variable, the thing that we decided to change, was the concentration, the strength of the acid. The dependent variable, the thing we were measuring, was the volume of hydrogen gas being produced every 10 seconds. But to make this a fair test, we only change one thing, and then we control the other things. So our control variables were the volume of acid. The first time I used 20 milliliters of acid. In the second experiment, it was 10 milliliters of acids and 10 milliliters of water, making the total volume 20. We kept that constant. It was all done at room temperature. That didn't change. The only thing we did change was the strength of that acid.